Chapter 5, Section 7. Expressions for the same area. Number 1. Explain why the diagram shows that 6 times 3 plus 4 equals 6 times 3 plus 6 times 4. Well, if we look at the whole big rectangle, the area of a rectangle is base times height, and your base is 6, and your height is whatever 3 plus 4 is. So what we're kind of looking at is big rectangle, or the area, is actually equal to the small one, the 6 by 3, which is 18, plus the medium one, which is 6 by 4, or 24. So the big rectangle equals small rectangle plus the median, or the medium rectangle. If you want to show that with the numbers, 6 times 3 plus 4, 3 plus 4 is 7. And we saw that that equals 18 plus 24. 18 plus 24 is 42. Also, 6 times 7 is 42. So those are all the same. Number 2, draw a diagram to show that 5 times x plus 2 equals 5 times x plus 5 times 2. So I need a big rectangle that's going to be a 5 times an x and a 2, and I'll just separate out the the x and the 2. So the x plus 2 kind of happens like that. And that's number 1 and number 2. So applying the distributive property, to multiply out the factors, or to expand 4 times x plus 2 gives us 4x plus 8, so we know that the two expressions are equivalent. We can use a rectangle with side lengths of x plus 2 and 4 to illustrate that multiplication like we see on the right. So draw a diagram to show that n times 2n plus 5 and 2n squared plus 5n are equivalent. So we have another rectangle of some sort. One of the sides is going to be n, and let's make this look like a 2n and a 5. If we find the areas here, n times 2n is 2n squared, and n times 5 is 5n. So we just started with n times 2n plus 5, and we showed that if we add all the areas together, we get 2n squared plus 5n, which is exactly what we thought we should get. So go ahead and try a few more of those. Pause the video and come back when you're ready for the next part. In number 4, they're asking, for each expression, use the distributive property to write an equivalent expression. If you get stuck, consider drawing a diagram. So the distributive property is really just saying, I'm going to say 6 times 1/3 n, plus I'm also going to have 6 times 2. Well, 6 times 1/3 is 6/3. 6 divided by 3 reduces to 2, plus we've still got that n there, plus 12. Distributive property here, p times 4p gets us 4p squared, plus p times 9 is 9p. And with c, 5r times r is 5r squared. 5r times 3/5 is going to be 3/5 times 5r. If we do that, 3 times 5 is 15, or 5 and 5 will cancel out, and we get 5r squared plus 3r. Go ahead and pause the video and try the next part. Alright. Using diagrams to find equivalent quadratic expressions. Here is a diagram of a rectangle with side lengths x plus 1 and x plus 3. Use this diagram to show that x plus 1 times x plus 3 and x squared plus 4x plus 3 are equivalent expressions. So if we go in here, x times x for this rectangle gets us x squared. X times 3 gets us 3x. 1 times x gets us 1x. And 1 times 3 is 3. So x squared plus 3x plus another x plus 3 comes down 3x and another x makes 4x, plus we still have that 3, plus we still have that x squared from the very beginning. All right, go ahead and pause the video and try the back side. So draw some diagrams to help you write equivalent expressions for each of the following. So we have x plus 2 times x plus 4, so let's get some rectangle-y things going. We have x plus 2 and x plus 4. X times x is still x squared. X times 2 is 2x. 4 times x is 4x. And 4 times 2 is 8. So we get an x squared plus 2x plus 4x plus 8. And that becomes x squared plus 6x plus 8. X plus 5 squared is a little bit weird, but squared really means times itself. So we're really looking at x plus 5 times x plus 5. Something like this, where we have an x and a 5 and an x and a 5. Once again, x times x is x squared. X times 5 is 5x. 5 times x is 5x, and 5 times 5 is 25. So we have an x squared plus 5x plus another 5x plus 25. And when we simplify that, we get x squared plus 10x plus 25 as our final answer. Number 7, we have a 2x plus 1 times an x plus 3. So we have a 2x and a 1. We also have an x and a 3. So 2x times 1x would be 2x squared. X times 1 is just x. 3 times 2x is 6x. And 3 times 1 is 3. So if I combine my two x's here to save myself a little bit of space because I didn't give myself a lot of writing room, then I can make this say 2x squared plus 6x, and that x is a total of 7x plus 3. And then the last one is all variables. So the most we can do with this is to start an x plus m and an x plus n. X times x is x squared. X times m will be mx. N times x will be nx. And n times m will be mn. And I'm just putting in that order because it's alphabetical. Now, I don't know what numbers m and n are, so I can't really combine them. The most I can get here is x squared plus mx plus nx plus mn. So go ahead and pause the video and try the next one. All right, write an equivalent expression for each expression without drawing a diagram. So if we try to FOIL here, x times x gets us x squared. X times 6 is a 6x. 2 times x is 2x. And 2 times 6 is 12. So when we combine those, or simplify that, we get x squared plus 8x plus 12. Number 10, if I have x times 2x, that's 2x squared. X times 10 will be 10x. 5 times 2x is another 10x. And 5 times 10 is 50. So we get 2x squared plus 20x plus 50. So our challenge here is x plus 4 squared equivalent to 2x squared plus 8x plus 8. Let's find out. X plus 4 times x plus 4 is going to be x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. So x squared plus 8x plus 16 is not the same as 2x squared plus 8x plus 8. Our summary: sometimes a quadratic expression is a product of binomials. Binomials just mean anything that you have two terms, x plus 2 times x plus 3. Those binomials are each a linear expression, and we can write the equivalent expression by thinking about each factor, the x plus 2 and the x plus 3, as sides of a rectangle. Adding the areas of the 4 sub-rectangles also gives the area of the big rectangle. That means that x plus 2 times x plus 3 is equivalent to x squared plus 5x plus 6. And that is lesson 7.